Hello, all. Today I'll be walking you through my blog, which I have written after implementing my main project under Dr. Park's data mining class. And I have selected to work on mango leaf disease prediction dataset, where I have implemented six image classification algorithms uh, and learned lot of details about how image classification works. Uh, Thanks to the lectures of Dr. Park and our TA and Rubel, who has been really helpful. We have chosen the dataset from Kaggle, and the details of the dataset have been provided here. I have implemented the image classifiers for six algorithms listed here. Uh, my Let's go through the contribution that I have done. I have imported the dataset and basically done some pre-processing. I have uh, splitted the data into training, validation, and test set so that I can train my model, validate it, and then finally test it on certain part of the data. I have performed initially some exploratory data analysis so that I can basically understand the data. I can clean the data. I can reshape the data because the images are of different sizes. I can uh, switch between coloring or non-coloring data depending upon how I want to display it. And I have viewed the data. I have extracted certain features, reshaped the images, and like done some feature extraction on the data. I have normalized the data, and I have also done some label encoding on the data, and then prepared the train test and validation sets. Um, I have briefly explained each and every algorithm in my blog for our understanding, and also listed the results for my accuracy that the model gave, and also printed out the classification report. And in the end, I have calculated the results of all the models together and compared them. Uh, first of all, I have implemented convolutional neural network three times by doing a lot of hyperparameter tuning, which I have listed here. In total, 16 hyperparameters and different techniques were used, and uh, everything is explained in these three models. One of the model also had the highest accuracy out of all the six classification techniques. And next up, I uh, implemented the same technique. Before that, I also I also actually executed the accuracy graph and the loss graph for all the convolution neural network models, and then tried to predict the mango leaf disease successfully, wherein I could actually see the difference between the original disease and the predicted disease of any particular image from the validation test set. Similarly, I implemented the algorithm for support vector machines and explained its advantages and disadvantages, and uh, like uh, found out the accuracy for the model, and wrote its classification report. I repeated the same activity for random forest classifiers. I did the same for logistic regression. I also performed the same model training for k nearest neighbors classifiers. And finally, I ended it with Naive Bayes classifier, which was part of our second assignment. In the end, I actually compared all the results of the model and represented them graphically, where I found that my first convolutional neural network model had the highest accuracy, followed by random forest, and the second convolutional neural network model had the least accuracy because I was training it on a very large number of epochs, and the image, the data went through overfitting. And I would like to say that hyperparameter tuning was one of the best way to bring out the highest accuracy in my CNN model, and like I was able to predict the data and disease successfully from an original disease which was mentioned.